Good morning, everybody, or good afternoon, depending on where you're located. Hello, and welcome to the SAS versus NVMe Interface Smackdown webinar, hosted by the SCSI Trade Association. This webinar is meant to provide a comparison between the two storage interfaces and comparing and contrasting them to provide a closer look at what makes them highly adopted and what they're good at. For those of you who are new to storage, this will provide a good introduction to the interfaces and the organizations that make these standards happen. For those of you who are storage veterans, we hope this will provide a fun way to see the interfaces that you've known for a long time. And in the end, we hope that you learn something new from the webinar. From a housekeeping standpoint, we will have a Q&A at the end of the webinar. So if you happen to have a question, please type it in the Ask a Question box during the webinar, and we will get to as many as we can after the content is presented. Also, I'd like to request that you please provide feedback on the webinar throughout the Bright Talk. Okay, and here are today's presenters. My name is Cameron Brett, and I'm president of the SCSI Trade Association and a storage veteran of over 20 years. I'm also a director of enterprise and cloud marketing at Kioxia, which we used to be called Toshiba Memory. Here's Jonmichael Hands to do an introduction for himself.
Hey guys, this is Jonmichael. I am a strategic planner at Intel. I've been working on our NVMe SSDs since 2011, and I am co-chair of the NVM Express Marketing Workgroup, and I'm also right now currently serving as the co-chair of the SNIA STA Forum.
Okay, thanks, thanks, Jonmichael. And now I'd like to turn things over. Oh, Jonmichael, did you have anything else to say?
Nope.
Okay, and now I'd like to turn things over to Don Jeanette, our moderator and ring announcer for today's Smackdown webinar. Don, take it away.
Hello, everyone. Thanks for having me. To introduce myself, again, my name is Don Jeanette. I am at TRENDFOCUS. I've been at TRENDFOCUS for 6 years. Prior to TRENDFOCUS, I was in the marketing organization at Toshiba, previously Fujitsu, working with data center, OEM, and channel markets. And then also I've worked at Marvell in the past and some internet companies prior to that. So again, thanks for being here. And a little introduction on TRENDFOCUS. We were established in 1993. Founded by Mark Deenan. He is still the president of the company, runs the company. We have over 80 clients worldwide. We specialize in hard disk drives, SSDs, NAND analysis and forecasting, quarterly and long-term forecasts, published 4 times per year at the end of each quarter, periodic installments, executive briefs, basically major product announcements, executive briefs, our reports to our client base whenever we travel around the globe and meet with various companies around the globe. And of course, we're available for special consulting projects outside of our normal published reports. Our reports cover, again, hard drives, SSDs, end market consumptions, and cloud, hyperscale, and enterprise storage. Okay? So with that, I am going to jump into a couple slides for our market forecast. So, you know, as you can see here, this is all enterprise storage in exabytes, right? It relates to all storage devices, hard drives and SSDs. You can see here that SAS has been the connected storage device of choice, the dominant interface for many years now. It will be the dominant interface for years to come. Again, hard drives and SSDs combined. And as you can see right here, hard drives have definitely dominated this forecast when you factor in nearline hard disk drives. You know, as a reference point, nearline hard drives in the previously reported quarter, they did over 170 exabytes. This was only going to increase each year, each quarter and each year. And then to compare that to SSDs, they did about 20 exabytes in that same quarter, okay? But when we break out SSDs and we look at them by themselves, obviously PCIe NVMe jumps out, right? That is the dominant interface for SSDs currently and will continue to be in the future. 2019 was the tipping point. SSDs, PCIe did outship SAS and SATA combined. It was about just under 2 exabytes actually for the year, so it was a pretty close race throughout the year, but it did edge out SAS and SATA by just under 2 exabytes for the calendar year. So the pendulum has swung. There's no looking back now. NVMe is now the dominant interface for all enterprise SSDs, but with the inverse of that, you do still have to look at SAS and SATA. It still is, call it a third of the exabyte shipped, even in the out years. So still pretty good from a deployment perspective. Okay, and then as they relate to end markets, each one is going to be more favored or dominant depending on which market we talk to, and I'm going to go more into detail about that later on. Okay, so how do we get here? SCSI, SAS and SCSI has been around for a long time. Anyone in the audience that has listened to me present in the past, you might have heard this line before. You know, one of my friends in the industry, retired now, Harry Mason, always used the example that, you know, SCSI is like a Twinkie. It'll never die. It's always been around. It's going to be around for a number of years. So whenever he said that, we got a good chuckle on that. So we're continuing to say it in his honor. So, you know, it's been utilized for tape, disk, optical. It's evolved each generation to give customers better reliability, faster speeds. It's been with hard drives for many years, for decades. Later on, it did incorporate SSDs into its development and market deployments. But I think, however, you know, at that same time, SAS was being utilized for SSDs. It still is today to a great extent. But it was decided that a new protocol was needed to better utilize and exploit these newer speeds and attributes that were being realized with SSDs. So enter, you know, NVMe, NVM Express. There were some obviously challenges and delays at the get-go with any new technologies, but as of today, you know, we see these benefits. It's in our everyday lives. Jonmichael's obviously going to go into more details about these attributes later. But with that, let's get to each specific area. Okay, so I'll hand it over to Cam.
Okay, so here we go. All right, shall we, Jonmichael? Let's dig into this. So just a quick look at the background. Here's an overview of SAS and SCSI technology, as well as the organization that develops and markets the SAS standard. Both are well-mature and well-oiled machines. The first SCSI spec was published in 1986. That's probably before you were born, Jonmichael. And was originally called SASE, Al Shugart, in the 1970s. The very smart engineering folks who develop the specs these days are in the T10, which is a group under the Insights Committee, which is International Committee for Information Technology Standards, a very large organization that does standards worldwide. And the SCSI Trade Association is the marketing arm of that group. SCSI and SAS standards define the protocol, command set, and physical transport, not just one of them, but multiples. And was originally created to connect a variety of devices, mainly storage type of devices, and eventually settled on a focus of high performance, high reliability connectivity that supports SAS and SATA, hard drives and SSDs, as well as a fabric-like connectivity that spans the data center. So it's not just one type of device. It's a mature and proven technology that has produced 11 generations of technology, effectively doubling performance and growing capabilities with each generation, as well as a transition from parallel to serial connectivity. These groups are governed by committee chairs and officers in the T10 and by a board of directors for the SCSI Trade Association, and that is a group that I'm in. And over the years, there have been well over 50 member companies, probably closer to 100, although it would be difficult to get a truly accurate count. So that's a quick look at the organization. Here's a quick look at the SAS roadmap. The SAS roadmap consists of a set of specifications that cover the physical layer, protocol layer, and SCSI command layer. Although these are developed by distinct groups within the T10, they commonly align to generational releases like 12 gigabit per second SAS and 24 gig SAS. Most people are familiar with the physical layer specification names of SAS-2, SAS-3, SAS-4, and so on. This specifies the physical performance capabilities, which is typically doubling the effective performance with each generation. The physical layer is where the bulk of the notable features are introduced. You'll also notice that the SAS-3 link rate is 12 gigabit per second, and SAS-4 doesn't quite double the link rate. That's because the smart guys in the T10, smart men and women, determined that to achieve the effective performance to double, they only had to up the transmission rate to 22.5 gigabaud, which just think of that as the raw transfer data rate before factoring in overhead such as encoding. At this time, SAS-5 looks to keep along the same path, doubling effective performance by doubling the 22.5 gigabaud link rate. The other specifications introduce new commands and features for hard drives and SSDs, as well as managing connections for optimal operation of devices and connections. And now I'll turn it over to Jonmichael for an overview of NVMe.
Wow, yeah, it was pretty close, Cameron. I was born in 1985, so I'm just slightly older than SAS, apparently. Learned something new today.
All right.
Yeah, Cameron knows this, but it's kind of funny. I actually started my career at Sun Microsystems, and my first project was designing a SAS JBOD, the 6 gig SAS, which was still in development and prototype, and I was just handed basically the LSI expander, user's guide and schematics, and the SAS spec, and it was like, good luck. So that's how I learned SAS, and I remember benchmarking the first SSDs. But today I'm going to talk about NVMe. So I've been around storage protocols all the way since the start of my career, kind of accidentally, but NVMe was actually developed in 2011. That was the very first spec. Now, the actual first SSD was not until 2014. So it's a debate whether that was Samsung or Intel. Samsung will say they're first, but they shipped with an OEM, and it was not widely available. Intel shipped the P3700, of which I was the product manager at the time, and I ran the validation team for that product for the 2 years prior to that launch. So I've been working on NVMe since PlugFest #1. And so yeah, you really started seeing these in 2014. Now there were some PCIe SSDs prior to NVMe, obviously. Fusion IO had a lot of success prior to that with some PCIe SSDs, but it was a proprietary format, and we knew that NVMe would eventually win out because it's an industry standard. So that was one of the hallmarks of NVMe, was basically forming an open collection of industry standards around non-volatile memory. And one of the nice things on NVMe, it was kind of first principles thinking. So they said, what's wrong with all the storage protocols today? How do we develop one from the ground up that's high performance and low latency? So that's one of the reasons why PCIe was chosen for the interconnect, to start on NVM Express. It was already high performance, low latency, and it was scalable to multiple PCIe generations for performance and I/O transfer speed. Scalable, right? So we have new multi-core CPUs coming out. How do we take advantage of those? How do you make a scalable interface with high number of queues? We're going to talk a little bit about this later, and NVMe supports many more queues than SAS or SATA does today. And then the most important part was the streamlined protocol. So how do you remove all the legacy bloat? Hey, if it's a protocol designed for SSDs, you don't really need all the legacy stuff that was designed for hard drives. You can take all that out, and that was pretty nice. The first NVMe spec came in around, I think, 120 pages, something like that. So pretty lean compared to the SAS spec. And of course, being efficient. One of the hallmarks of NVMe is low latency overhead and efficient CPU utilization. So you're basically driving down the clock cycles required for an I/O. Kind of removing bottlenecks in the system of memory mapped I/O and uncacheable register reads, and I'll get into more about that in a little bit. But it really makes NVMe a really efficient CPU utilization for a number of IOPS. And the other part of it is the actual company around it. So NVM Express is now an organization. And there's many specifications that we publish, and I'll talk about that here in the roadmap on the slide. Hundreds of member companies. I think it's over 100 for sure. I don't know how many we are today. I can't, but we have a page on the NVMExpress.org website that shows all the member companies, and then there's 13 promoter companies that serve on the board of directors that show the direction of the technology. Okay, and so I'm going to talk a little bit about the roadmap. So today, basically, there's 3 NVM Express specifications. So we have the NVMe spec, which is basically the standard for PCIe solid-state drives. So it provides all the functionality of how you would build an NVMe SSD that runs on top of PCI Express, all the command set for I/O commands, for management, for the PCIe enumeration, for everything to actually fully form an SSD command set for a host to talk to the device. And then you have the NVMe over Fabric specification, which is basically how do you take all the efficientness of NVMe that was built in for low latency and scalable performance, and then build that on top of network fabrics that are not PCI Express. And we'll talk about that in a little bit, about how NVMe over Fabric kind of expands the scalability of NVM Express beyond just PCI Express and within the server, within the rack. And then you have the NVMe Management Interface specification, which is a specification designed to manage NVMe devices in-band and out-of-band. So out-of-band meaning agnostic to the operating system, and in-band kind of in the operating system. And you'll see, a handful of customers do management different ways. So NVMe has a pretty robust set of management for different types of customers. So the current spec is NVMe 1.4, and you can find that on nvmexpress.org. And the good thing about NVMe specs is they're all open. You can find them right on the website. Now, if you want to look at the new standards that are being developed for the next gen, you have to be a member. But for the currently released specifications, you can just go to the website and download the latest spec. And honestly, that's how I learned NVMe. With spec number 1, NVMe 1.0, I literally just downloaded the spec and read it, and it's much easier to understand. But it's nice that you can do that now right from the website and not have to have any membership stuff. So the big thing coming up is NVMe 2.0, and that's really we're going to overhaul NVMe and kind of refactor the specification into a base specification that contains all the commands and kind of integrating some of the stuff that was in the Fabric spec, and then we're going to have multiple namespace types and command sets. There's different types of devices coming out, like zone namespaces for high capacity QLC. We have key values, and of course the block command set that's used today on storage. So this NVMe 2.0 will really expose all that functionality. And then the transport specs are actually going to be broken out. So that's the big new thing in NVMe 2.0 that we're going to do, is break out the PCIe transport and all the other transports, like stuff like Ethernet and Fiber Channel and InfiniBand, into individual transport specs. And then you'll have the own command set specs, like I mentioned, for the different command sets like key value, zone namespace, and of course block.
Sorry,
all right.
Like SCSI.
Certainly more complicated than it used to be, for sure.
Yeah. All right. Thanks, gentlemen. I think after hearing from both of them about the organization, the roadmaps from each side, I think we can all agree that both sides have critical mass, they have a number of member companies, expertise, et cetera. I think, on each side of the spectrum, they continue to bring, continuous products, faster, enhanced, feature-rich solutions, viable roadmaps for the future for each respective technology. But, that's been playing nice. So now let's get to the Smackdown, and let's see how they compare when it comes to performance and scalability.
Okay, thanks, Don. All right, let's jump right in here. Okay, when you look at the performance numbers, kind of looks like NVMe PCIe SSDs are the clear winners. Well, the numbers on the spec sheets may be higher, but there's more to it than that behind the scenes. Both types of devices demonstrate their performance through connections, which are SAS links or PCIe lanes. SAS drives are commonly used in a single lane configuration for servers, and some storage or specialized deployments can take advantage of 2 links. So it'll be either in dual port, wide port, multi-link, so basically doubling the number of links. Comparing a lane-by-lane comparison, a 24 gig SAS lane outperforms a single PCIe lane at 2.4 gigabytes a second versus 2.2 gigabytes a second throughput, or about 20% more. Now, if SAS wanted to quadruple the lanes in a device, we'd have better performance than a typical by 4 PCIe SSD, but it's not likely that SAS will do that. At this point, probably not. Wide port was enough. Just a quick note, I do see a slight error in the wide port bandwidth, which should be 4.8 gigabytes a second, not 48. So my apologies for that. And I guess if I just left it at 48, it would even outperform a by 16 PCIe drive. One other thing to note, that a typical PCI SSD uses 4 lanes, which also means it uses more host resources that are required per lane to connect and manage the drive, such as a little bit more memory, a little bit more power. Not so with SAS drives. They typically use 1 or possibly 2 links. And just as an aside, for common deployments, most applications don't need 1 million IOPS per drive. For PCIe drives, you may use up some PCIe lanes and host resources to service that level of performance.
Cameron, there's no room for errors in the Smackdown. There's no typos in the Smackdown. Okay, so NVMe was designed to be scalable and high performance. So one of the first things you'll notice, is the queue depth. So SATA supports 1 queue with a queue depth of 32, and SAS, Cameron, correct me if I'm wrong here, if SAS has changed since I understand it, supports 1 queue with a total of 256 queue depth. NVMe was designed to support 65K queues and 65K commands per queue. That's 65,000. Yeah, now I've seen some PCIe Gen 4 drives today that support, like up to 32 virtual functions, with the virtualization, and then 64 to 128 queues per virtual function, and then in each of those queues you can support up to 64,000 queues depending on the operating system. So it was sure designed to be scalable, and this is really important for steps going forward for virtualization and containerized architecture and cloud-based storage. But going back to the basics, there's 2 parts. There's 2 parts to being scalable. One is the bandwidth and latency thing. So for the bandwidth, you're seeing, this is kind of how I view the world here on the right, with not just the interface speeds, but what can an actual SSD deliver on performance after the overhead. And the overhead meaning, after every single, NVMe command is 64-byte command, and so there's overhead on top of the PCIe from running on top, and you have the overhead of the PCIe interface. But after all said and done, is a PCIe Gen 4 drive can reach up to about 7.2 to 7.4 gigabytes a second if it's really optimized. And today, right, I think 23 times something like that faster than SATA. And most, as Cameron mentioned, most of the SAS, SAS 24 gig is brand new, and I think Kioxia has announced the drive there, but there's not really anything shipping in the market today. Or there are Gen 4 drives that have been announced that are shipping today, and on PCIe, and they're really competing today against SAS 12 gigabit per second SSDs, and most of the configurations are by 1. So you're seeing about a 6x performance improvement from a SAS 12 gigabit per second SSD. That's by 1, going to PCIe Gen 4 by 4, and we're not stopping there. PCIe has developed Gen 5 and Gen 6 to keep doubling the bandwidth, and Gen 5 SSDs, NVMe SSDs, will be able to do over 14 gigabytes a second bandwidth, and up to 3.5 million IOPS. So yeah, the scalability keeps continuing to be there. The other part of this on NVMe is just the latency overhead. So one of the things, and I'll talk a lot about, how NVMe does this specifically, and it has to do with the really core principles of the design that were really amazing, and they were really smart when they designed the interface. But if you look at latency today of an HBA, and again, when I measured this 5 years ago, it was about 25 microseconds overhead for an HBA or RAID card. But with SAS connectivity, you have to attach the drive through a host bus adapter or a RAID card, where NVMe, you're basically attaching it directly to the CPU via PCIe. And this latency improvement is, today about somewhere between, I will say, 15 to 25 microseconds, which, for hard drives didn't matter, right? Hard drives are in the millisecond, microsecond access time for random access. So, 25 microseconds didn't matter. But for NAND SSDs that have a T-read of say 50 to 100 microseconds, 25 microseconds is a pretty big chunk. But it's really it's really important as we move to storage class memory, like our Intel Optane SSDs today are somewhere between 6 and 8 microseconds average latency, depending on the driver stack, and a 25 microsecond latency hit from an HBA would be absolutely catastrophic to that performance. So when you start looking, NVMe was designed from the ground up to be able to scale to storage class memory. The other part of NVMe, which is really important, is I said the core principles of the design to reduce overhead of the interface, and I cannot stress this enough. It's literally right in the version 1 of the spec, but NVMe does not require uncacheable MMIO register reads in the command submission or completion path, and a maximum of 1 MMIO register write is necessary in the command submission path. So this sounds, just like technical talk, but reducing from 7 uncacheable register reads in HCI, significantly reduces the latency overhead, down to where now really new innovative drivers can take advantage of this performance. Now, when we started NVMe in 2013 or so, I was benchmarking some drives. 2 NVMe drives at 1 million IOPS would take a 2-socket Xeon to its knees, basically to 100% CPU utilization. Just to show you how far we've come in NVMe, if you go to the spdk.io website, which is one of the open source NVMe driver development kits for NVMe, they have a polling driver that they were able to demonstrate 10 million IOPS on a single CPU thread. I'll just say that again to state how efficient NVMe is. 10 million IOPS on a single CPU thread, and you can go through he has Ben Walker, who is one of the authors in SPDK. He did a presentation on this at one of the SNIA events. It's on the SNIA YouTube channel, and you should go read the blog. Basically goes through all the stuff that they did, but basically he just took advantage of all that stuff. Basically optimizing the CPU cache line, optimizing batching completion and submission queues, and basically showing off all the efficient architecture of NVMe. So it's really, from the core principles, designed to be insanely efficient and scalable. And again, you can only do that when you start from the ground up on a first principles design approach. All right, so I think that covers, the last thing I forgot to cover was, PCIe was meant to scale, in a server, in a desktop, or within a rack. It is not meant to scale outside of the rack. So NVMe River Fabrics is what we have to scale outside of the rack, and it's probably a lot more than I have time to go into today, but lots of smart people are working on that to scale the fabrics on Ethernet, on RDMA, on Fiber Channel, and InfiniBand, to be able to actually take all that good stuff I just talked about with NVMe and pipe it on top of things that are not PCI Express.
Okay, I'll give you your performance scaling, and that NVMe UF scales outside the box. And just a quick note that NVMe UF looks a lot like a SAN. And that's been around for decades with SAS. SAS performance may not scale at the same rate as NVMe, but SAS scales in a different way. SAS was designed to accommodate configurations of up to 64,000 end devices. Okay, I've never heard of a configuration like that, given you need a whole lot of memory for routing tables. But it is possible, and many other scalable configurations are possible with SAS, and it isn't uncommon to have configurations of 2,000 devices or more in practice. The SAN is built on SCSI technology, with Fiber Channel being probably the most common interconnect, which of course runs the SCSI command set. It is common to run SAS-based arrays connected to the SAN, and the SAN typically has multiple hosts, and you can dynamically scale SAS storage by adding disks or arrays dynamically without taking down the system. Just plug it in and the storage gets automatically added while the system continues to run. And how scalable can SAS go in distance? SAS cabling options give it rack-to-rack, room-to-room, and data center-to-data center connection options. Now that's what I call scalability. Don?
All right. Okay, round one complete. Thank you very much, Jonmichael and Cam. I think after that round, with performance at the device level, let's score one for NVMe. However, I think when Cam talked about scalability outside the box, we can say as of today, SAS may have the benefit here. So with that said, let's continue the Smackdown, go on to round two, and see what the gentlemen have to say about flexibility.
All right. So I think PCI Express is pretty flexible. I don't know what happened to this picture here on the slide as uploading to BreakTalk, but that in the middle there, that's an E1.S with a 15 millimeter enclosure. So I'm going to talk a little bit about form factors for a second. One of the things of PCIe is today you have 3 different form factors that are mainstream. You have add-in card Chem, which is kind of the general purpose, form factor for PCI Express, standard compatibility. You have different sizes and heights. This is a low-profile card that most SSDs use, and then you have M.2s for mobile devices, laptops, and then you have the 110 millimeter that was used in data center and hyperscale. And then you have U.2, which makes up the majority of it, the NVMe SSDs today, which is basically just the 2.5-inch form factor. That, yes, we borrowed from the SAS world of hard drives for the physical dimensions. And this uses the U.2 connector, which is for latency PCI Express. And now one of the things we're moving to in the next generation it's really going to start with Gen 4, but really take off at Gen 5, is the transition from these legacy PCIe form factors for purpose-built data center form factors for NVMe SSDs. And this is called EDSFF. And we actually, unfortunately, we don't have enough time to go through all the goodness of EDSFF today, but you guys are lucky. We did a webcast last week with SNIA with some of the architects and key people designing the specification from Facebook, Microsoft, Dell, and HP that went over all the new stuff in the spec and their use cases. But basically, EDSFF is purpose-built NVMe storage for data center design. So E1 is focused around 1U, and so you have E1.L for really high capacity drives, and then you have E1.S for scalable performance and mainstream compute use, and then you have E3, which is optimized for 2U compute and storage, and then you have these higher power than U.2 to scale to those higher PCIe Gen 5 speeds I talked about, to different device types, like, say, for instance, CXL persistent memory or accelerators or computational storage. So really, the PCI Express gives you a bunch of scalability in the form factors. The other thing is that today you'll see PCI Express on all three interfaces from Intel, right? We have TLC, we have QLC, and storage class memory, our Optane SSDs. So our vision, Intel's vision, for NVMe was you have one interface. And then you have different device types, different classes of drives based on the storage media, right? So QLC is for high-capacity storage, TLC is for mainstream performance, and Optane is for the highest performance, lowest latency, workloads. And so you have all that, the scales on one common interface in common form factors. And then you have these purpose-built designs that give you flexibility within those, designs to basically scale the performance, and capacity and, number of drives per rack unit. The other thing I'll say about flexibility is, PCIe is pretty ubiquitous, right? You see it all the way down to mobile phones, chipsets, you see it in desktops and workstations, you see it in servers, you see it, basically, it is, PCIe SIG is a huge membership and a broad number of companies that have PCIe IP. So for PCIe being the attach of NVMe, and NVMe is really just, the command set and register set that go on top of it, you can have a lot of scalable types of, different form factors, different uses, and different attach points. So NVMe devices can attach through the PCI Express on the CPU. They can attach through PCI Express on a PCIe switch. They can attach through PCIe across a PCIe retimer for link extension or port expansion. With a switch, you can have an HBA RAID card today that support SAS and SATA. They also support NVMe. So basically, any way you can attach a drive, there's different use cases, but the key there is that SAS, I believe, is just kind of ran by a few vendors on the ecosystem side. As far as the infrastructure, there's only a handful of vendors that have SAS IP, where PCI Express is pretty ubiquitous, and that's really why we think that NVMe is very flexible. And of course, I mentioned the storage consolidation. So when you have these form factors that are purpose-built, designed in tandem with a 1U server, they're really designed for SSDs, kind of removing the legacy bottlenecks, that you had around these form factors that were designed, to mechanically be the same kind of size as the hard drive.
All right. Well, that is good flexibility at a drive level. But with SAS, we look at flexibility at a higher level, at an architectural level. SAS does have the tried and true 2.5-inch and 3.5-inch drive form factors, which may seem boring and not so innovative. Excuse me. But SAS flexibility comes in other very powerful ways. SAS connections and backplanes natively support both SAS and SATA protocols, as well as hard drives and SSDs. And let's not forget about SAS-based optical and tape drives too. So those are a few more device types that are supported on a SAS connection than NVMe does today. With the single interface, which we will call SAS, you can create fully tiered environments that service high-performance applications with a high-performance or a caching layer, a warm tier that houses large amounts of regularly accessed data, And of course, on the right, you have an archival cold tier that uses low-cost, high-capacity hard drives. And so that's what we call flexibility at an architectural level. Now all we need is some way of a backplane supporting all three interfaces.
All right. Thank you. Thank you, gentlemen. So there you have it, round two. Thanks, guys. I think, I think with all the form factors on the PCIe discussion that Jonmichael gave, I think they could be a good option to have. I think, others might say it could be a bad option depending on your view on SKU management, maybe qual or vendor count resources needed for multiple form factors you might be looking at, future-proofing designs that you have, making design decisions today, and you hope and ensure that these options are going to be available years out, 3, 5, 5+ years out. Nonetheless, I think, I'm going to go with more is better. It's a good situation to be in, right? Whereas SAS with hard drives and SSDs, again, like Cam said, the form factors, mainly 2.5-inch and 3.5-inch. What you have today. What you're going to have years from now. However, I would say, the design options might lag versus your PCIe options, okay? So now let's get on to round three. Let's see how we match up against with manageability and serviceability.
Okay, now that we're on the manageability and serviceability, I'll bet some of you may know where I'm going to go with this one. Managing and servicing storage isn't easy, and it's taken decades of continual refinement. The T10 created a specification called SCSI Enclosure Services, or SES. It defines in-band and out-of-band ways to communicate with the array and the devices inside. Applications can monitor enclosure services outside of the SAS connection with a BMC or a baseboard management controller, and that reports the health and management status of the enclosure and devices by an outside connection, which I think Jonmichael touched on earlier. This outside connection is used in case there's a problem with the SAS connection that prevents reporting of information. Now, hot plug is one of those things that's proven to be pretty difficult, especially surprise hot plug. Surprise hot plug occurs when unexpectedly a drive needs to be replaced, and you can't quiesce the connection or silence the connection, carefully before swapping out the drives. SAS has been doing this for a really long time, and it certainly helps to have a controller. That controller that I guess in some ways can be viewed as a negative, but in this case, if you have a controller in there to manage a connection, then the host system doesn't have to worry about it. The CPU and the PCIe doesn't have to worry about managing that connection. The controller takes care of all the quiescing of the bus and then spinning up a new device. And all major IT OEMs have management tools that work with and support SES. It's a well-understood way to look under the hood and ensure things are running smoothly. SES is done so well that, my mic drop moment.
Ooh,
the floor is yours, Jonmichael.
That was brutal. Okay, so one of the things that NVMe stole from SAS was the SES enclosure management was part of the NVMe 1.1, which again you don't need to reinvent the wheel on an operating a enclosure or JBOD that you have slot management and fan management and stuff like that. So actually, to Cameron's point, we leveraged some of that. But NVMe was designed from the ground up basically to have in-band and out-of-band management of NVMe devices. So out-of-band, so say for instance, you were a enterprise server OEM and you support, multiple operating systems like, Linux and VMware and Windows, but you want one management console. So the way to do that is to basically build all the management commands into this out-of-band management interface. So we have the NVMe command set that runs on top of SMBus. It also runs on top of PCIe, tunneled through the PCIe vendor-defined messages if you want. Actually the most common way people manage NVMe devices is the in-band. So in Hyperscale today, it's very common just to use in-band management, which means you're sending the commands right directly to the admin queue to the drive. And so On the NVMe SSDs, the controller is basically on the SSD itself, and you're directly attached to the PCIe bus. So you can have stuff like open source software that manages the drive. So in NVMe today, one of the awesome things we have is all the management capability. The official management capability for NVMe is just built into the operating system. So if you install NVMe CLI in Linux, you can basically run any single command you can possibly think of in NVM Express that's in the spec through the command line, and it's all just basically built into the tool. And then there's some nice commands that are to make it easy to read smart, to manage the health of the drive. So I just recently did a webcast. Again, I have to plug that one as well through NVM Express that covers all that management stuff and how we actually look at health reporting and monitoring of NVMe SSDs. So, and I see somebody asked me for the link of the SNIA one. It's on the SNIA YouTube page. I'll post I'll attach those links after this for all those ones that we're not going to have time to go into today. But yeah, again, check out the management interface spec. Yeah, again, it's basically fully functionable management, for inbound and outbound. Now, I'll get the camera. The one thing I'll give SAS and SATA was, I used to run the validation team for our NVMe SSDs, and hot plug testing was incredibly challenging with NVMe. You had to have this, fine symphony of the PCIe supporting unplanned power loss. For the NVMe SSD, you have to have the PCIe bus be able to detect when a device goes away, and you have to have the NVMe driver be able to communicate in that to say, when commands are getting rejected when there's no device present. So you basically had to have all three of those things working in tandem in perfectly sync, or else hot plug wouldn't work on PCIe. Now, lucky since then, there's been a ton of work in this topic, and largely in a software-based system, everything works beautifully with surprise hot plug and removal on NVMe today. But all to say, it was certainly a lot harder to get to that point than we anticipated it, and it was basically because of what Cameron just mentioned, is that if you have a RAID card or HBA in the middle that can take care of and isolate those events, that it makes that a lot easier. So I'll say that. I'll leave it at that.
Thanks. All right, round 3 is over. I think after that discussion, some folks, maybe they'll come to the conclusion that some of the core building blocks from all those decades developing and fine-tuning SAS and SCSI, NVMe was able to build on that, take it to the next level, really, again, utilize and exploit the SSDs for what they could be used for. And then but overall, with all that said, who is the winner in all this, right? So I think it's going to depend on the market, right? So the markets are basically the winner. So I'm giving you the winner in a 4-part answer. I feel like a college exam here. So, take a moment to kind of digest each pie chart here and where each protocol is consumed with those percentages. 3 main markets: the hyperscale market, the enterprise market, traditional enterprise market, and then the channel market. So if we talk to, the channel market and the SATA SSDs first, if we've learned anything from history, anyone that's been in storage for a long time, when it relates to hard drives, especially hard drives and now SSDs, the channel most always lags other markets in transitioning to new interfaces. I'll just point you to parallel ATA, parallel SCSI, 68 and 80 pin, fiber channel. Think about some of the efforts some companies did to try to get that going in the channel, but historically it has always taken longer, okay? Why is that, right? Legacy solutions, multiple vendors continuing to offer this protocol to their customers. If they have it, they'll buy it. These tier 2, tier 3 smaller customers, whether it's budget decisions or constraints, strategies when it comes to pricing tiers for performance and pricing, they may choose to keep SATA around with the mentality of basically it's not broke, don't fix it, right? But again, SATA is within that SAS infrastructure, right? So that's there for a long time there. Expertise to transition, right? They're not ready to go to NVMe in that market. And then, again, SSD vendors, as long as they offer it and they're not forcing their hands with EOLing a certain protocol, and if it's there, they'll buy it. When we talk about the OEM market, obviously, and SAS SSDs and exabytes, the traditional OEM enterprise market dominates that consumption. You know, and if anyone has heard me speak of the end market consumption before, you might have heard this before. Think of major OEMs and qual cycles, engineering expertise, needing to maintain multiple protocols becomes a challenge. If they are taking one protocol, this one being SAS, they need to have 2 or 3, vendors to ensure their products launching into the market. You have a primary vendor, a backup vendor, even a third vendor that they need like-for-like attributes for those products. So going to different protocols and newer technologies is slow for them. And even after all that criteria is met, and they do add SKUs with this newer, higher performing protocol into their system, it's usually going to be at the higher swim lane, higher performance, higher price point SKU, right? So your highest performing solution, NVMe based, will be your highest price. Business 101, highest price is usually lowest volume. Lowest price is usually highest volume. So as they add these NVMe SKUs, they would EOL lower price, lower performing legacy SKUs, call it SAS or SATA. So if you're at 1 to 1.5 design cycles per year, right, it's going to take a long time to see a given volume protocol be EOL from those line cards or offerings from those OEM customers. Now let's go to Hyperscale and PCIe. So PCIe, Hyperscale dominates, right? That is by far the vast majority of the consumption for all PCIe NVMe SSDs in the world. Why is that? They're not beholden to end customers, right? They don't have to worry about pricing tiers. They don't take storage devices, bend metal around them, and sell them to end customers for different performance levels. They have their own data centers, right? These companies are giving us cheap storage. They're giving us storage that is fast enough, that is good enough. At its most basic example, I always say, they're giving us, search pages to buy new shoes for our kids, new toys to go camping these days or what have you. They're not beholden to end customers with hardware, okay, if that makes sense. And then for hard drives, again, I mentioned earlier that the vast amount of exabytes that ship each quarter for SAS and SATA hard disk drives, over 170 exabytes just in Q1, Hyperscale does dominate the exabytes for that as well. When you're selling storage devices at just over 1 penny per gigabyte, that's hard to compete with other technologies, even in the foreseeable future. If we look at it from a unit base, just for some color here, it's about 50-50 of the units go to traditional enterprise customers, 50% of the units go to Hyperscale, but we're looking at it here in exabytes. Obviously, Hyperscale companies are the ones that are the driving force consuming and buying the higher capacity nearline drives. And I will say this, hard drive companies, there's 3 left. The nearline hard drive market, SAS and SATA, is the holy grail of what's left for these companies. They have a vast amount of resources, effort, strategies, and initiatives to make sure they execute in this market, and rightfully so. You saw my forecast chart at the beginning of the presentation where this market from an exabyte perspective will just continue to flourish with new technologies enabling these higher aerial densities to ship in this market. Okay. All right. So, in summary, right, we've seen all the slides. I think we can hopefully agree, SAS and NVMe are going to be around for many years to come, each having their own markets they excel in, right, end markets. Like many technologies, SAS is going to be around a lot longer than people might think or might want, right, for some of the reasons that I've talked about previously. Obviously, NVMe is designed for the future of computing. It's already dominated one market segment. It will continue to inch into other markets with each passing year, with each new design cycle, with each new cost benefit and pricing takedowns. You will see integration into other markets. I think, but each market will transition at their own rate for different reasons. So with that, I am going to transition to questions. So I will field the first question. Let's see what we have here. So Cam, I think I'm going to give this one to you. When do you see 24 gig SAS coming to market?
Okay, good question. 24 gig SAS has been, I guess, announced, and the SCSI Trade Association and the T10 have been furiously working behind the scenes. The ecosystem is starting to develop. There has been a one Plugfest already, and the second Plugfest was thwarted by the pandemic, but that is still being planned, and that will happen eventually. But it certainly will not stop the development efforts. And so to finally get to answering the question, 24 gig SAS you'll probably see some emergence of it before the end of the year, but certainly in the first half of 2021.
All right. Jonmichael, for you, referring to the slide on form factors, why does EDSFF have so many options?
Yeah, there's kind of a misconception that there's so many EDSFF form factors. One is they all use the exact same connector, and there's a scalable connector that goes from by 4, by 8, or by 16, but they all use the same connector and pinout for the SSD, and the variants are really for different purpose-built designs. So like the 1U long is for high-capacity SSDs, the E1.S is for mid-range capacity TLC and 1U servers, and the 1 means 1U server, and then the E3 is really designed for 2U servers, but they all use the same connector, and there's a lot of reuse between them. And again, not dissimilar from today you have a low-profile add-in card, there's full-height add-in cards or whatever. E3 has some different sizes, but they're really the same form factor underneath, and there is planned to be a ton of reuse between the form factors.
All right, thank you. Maybe this is for both of you. Cam, maybe if you want to go first, and I could chime in if you like. What about dual-port PCIe? How will that affect SAS?
Well, let Jonmichael take his pass at it since it's leading off with PCIe.
Yeah, sure. I mean, I think you've seen, we'll just say, some of the industry leaders in this space, like Dell EMC, for instance, bringing their top-tier performance enterprise storage arrays like PowerMax to all NVMe already. And you have all flash array vendors like Pure and others doing all NVMe. So but as we just talked about, these transitions happen kind of slow. In the enterprise storage space, I think we're looking at about 3 years before NVMe takes over SAS in enterprise storage market in that when that's high availability systems. But again, we're already seeing it in the top tier for performance, and I think it's only a matter of time before it hits the mainstream.
All right, thank you. The next one I'll take, it's for a definitional perspective. Please define the 3 channels, specifically channel, what does it include, and does it include PC manufacturers? So in the 3 market segments, enterprise, traditional OEM, it is the major OEM companies for enterprise server and storage in the world that dictate most of the volume there. And then for hyperscale, tier 1 hyperscale companies, you could probably name, the 6 or so right off the top of your head that dictate all the volume there. And then once those are backed out from a unit and exabyte perspective, all the smaller companies are left over. That's going to be the channel / aftermarket, all the lower tier companies that don't dictate the volume in those first 2 categories. Cam, I think the next, yep, go ahead.
I was going to say, I see something there about NVMe HDDs. You want to just tackle that one quick?
Yeah.
Sure,
so,
yeah.
Go ahead, Jonmichael. You start.
Yeah. Well, yeah. If any of you guys saw the Open Compute Virtual Summit this year, there were some presentations by Microsoft, WD, and Seagate, around this topic. But potentially, as I mentioned, PCIe is a ubiquitous interface that many companies have IP around. So there's the question that the hyperscale guys pose to the industry, mainly WD and Seagate, who are responsible for the majority of these hard drive shipments into the cloud space. Hey, could for instance you guys build a hard drive on NVMe, and they already have the what that would look like. And again, with what I mentioned in NVMe 2.0, where we have different command sets, it actually would be not very burdensome to the NVMe architecture to if they wanted to go do that. You could do it in a way that didn't add any complexity or burden the SSDs whatsoever. And in that case, the more the merrier.
Don, you got any thoughts on that from what you're seeing?
Well, I'm always thinking of, an interface's capability, and when I'm thinking about hard drives, I'm thinking of the data rate going from the media to the head and through the connector. Might be a little overkill.
Yeah, they're mostly talking about they're mostly talking about like PCIe Gen 3 by 1 for hard drives or something like that. But again, yeah, I think we're pretty far off. I think we're at least 3 or 4 years away from seeing that in the real world if it happens. But yeah, we'll see.
Okay, got it. Cam, I'm going to bring this over to you, and then if you'd like me to add on, I will. I've recently seen some news on value SAS SSDs. Will value SAS be replacing SATA?
We hope anything will replace SATA. I think SATA's run its course. We have a campaign that we're doing called Life After SATA, and part of that is something we call value SAS SSDs. And the easiest way to think of it is that you get a single-ported SAS SSD at a much more closely aligned price to SATA. So it's kind of defeatured, not quite as high-performing as your typical SAS drive, but it's a lot more price comparable. And what you end up getting is a lot more performance, more reliability, for the dollar, and that makes it a very, very easy way to switch away from SATA. And it's typically targeted at servers being single-ported, and the vast majority of servers these days come with some sort of SAS connection, whether it be RAID or just a SAS I/O controller. So value SAS is definitely gaining some traction, and there are we see some good adoption of it coming from the big server guys.
All right, thank you. Okay, so Cam, we're at the top of the hour. I don't know if did you want to do some closing comments, or what do you think?
Yeah, I guess thank you everybody for joining. Honestly, there's still a bunch more questions coming in. We certainly thank you all for attending today and submitting questions. So our commitment will certainly be to answer each and every one of the questions, either in a blog or directly to you. I guess with that, any other closing thoughts, Don or Jonmichael?
Yeah, I think the one is, you notice we didn't talk about SATA very much. I don't think that there's any, comments about SATA. I think we would all in the industry like to sunset it as quickly as possible. I think, as you saw, the drives are just getting so fast. There's no reason to bottleneck the drives with a SATA interface on them anymore. So.
All right, and I would just like to say thanks for having me, and it was a pleasure moderating the panel. And thank you to the audience.
Okay, thank you everybody for joining. Please don't forget to provide feedback on the webinar. We certainly appreciate it. Thank you all for joining, and have a great day.
Thanks for the time, guys. Bye-bye.
Bye-bye.